Hello, am I audible? Am I audible? Good morning, everyone. Shall we start with the class? If I'm audible. Hello. Hello. Yes, Benison, good morning. And am I audible?
Yes, ma'am.
Okay. Okay, let me share my screen really. Okay. Is it visible to you all? The screen? My screen is visible?
Yes, ma'am.
Okay. So last class we were doing this fillet wells, like how the strength of your fillet well, how to determine the strength of your fillet wells. Fillet wells were what? This one. Let me take the pencil. Okay. So your fillet well was what? Your fillet weld was the one which used to be in isosceles. The suppose these are the two plates you want to join. So this is, if you see the side view, this portion is your what? Is your this triangle is nothing but your, that means from side view if you see, this is your fillet wells. Okay. That means to join when you want to overlap two metal plates, or you want to two members, steel members, you want to connect or overlap each other, you want to join these two after overlapping, so you can use the fillet wells. Okay, so fillet wells are used here where you have to overlap two members together to join. Okay, when the members are connected, either it can be in T shape also, or this kind of structure, overlapping structure. So basically your strength was the strength of your fillet wells were what? Depending upon the shortest distance. Shortest distance was which one? This one was your, if you enlarge and see, okay, let me take this annotation. So if you enlarge and see, uh, triangle doesn't come. No. So this one, and this one. This is your right angle triangle. So this is nothing. Sorry, isosceles triangle. So you will have your what? This you will have your the max the your this thing now, the shortest distance, which is the strength of the well. Suppose this is your fillet well, the strength of these particular well will depend upon what? Depend upon the shortest distance. So that is, suppose this one, this is your shortest distance from here, the center. Okay, so this green one you're looking, the green one is nothing but your, this will decide your strength of the, this distance will decide your strength of the well. That means from this root of this well to the face of this well will determine this distance. This is the shortest distance, because you know when you measure from this root of the well to the face, suppose from here to till here, this point you measure, it is longer than obviously this. If this side also longer, and as you go from this point, that is the root of the well, to this end, it is becoming longer, the distance is becoming longer and longer, right? So this is your shortest distance, obviously, you know. So your strength will depend upon this, based upon this. So that is your nothing but your called your throat thickness. Okay, now what is your throat thickness? Your throat thickness is given. Your throat thickness is given by this one. Tt is equal to s by root 2. That means throat t suffix t, which is nothing but your strength. Okay, that is the throat thickness. This is your throat thickness. So the throat thickness is given by how much? This distance is given by how much? S by root 2. That is nothing but your 0.7 s. Okay, that is nothing but this one, 0.7 s. So because 1 by root 2 is 0.7, so s is here. So 0.7 s. That means directly also you can calculate your throat thickness, which is your s by root 2, or you can directly multiply it with 0.7s. I think some of them are in the lobby waiting. Okay, I'll unlock them. Okay, done. So this was the main thing. This is very important for your fillet wells, the throat thickness. So your throat thickness was what? Your throat thickness was 0.7 s, this one. So once you know your throat thickness, okay. Once you know this one, that is your throat thickness, this distance, once you know this throat thickness, what you can find out? You can find out the design stress, which is your given by this one. FWD is equal to how much? Fu by root 3 gamma mw. Now, I told you, you have to have your IS code. Let me, okay. So if you will have your, you will see in your IS code here, yeah, here only. So what happens in the IS code? This is your Fu. Fu is the value of Fu is how much? The value is ultimate stress of the well. That means this is, suppose you're taking Fe 410. Okay, then how much it will be your ultimate stress? 410. Gamma mw is what? This gamma mw. This gamma mw is your partial safety factor. The value of this partial safety factor, this one, the value of this partial safety factor will be given by at your IS code. This is mentioned in your IS code. Okay, so IS code here, you will see IS 800, you need these IS 800 2007. So this one is your IS 800 2007. Here you see in the class page number 75, sorry, page number 30, table 7. Now, so we will go and see the table 7, sorry, table 5. In the table 5, you are going to get your partial safety factors. So you can see this IS code, just download this IS code, or if you want, you can ask me, I'll share you. Okay, let me see if I can share here itself in the meeting itself. Okay, I'll just check later. Just remind me. So you have to have your IS 800 2007 for the Indian Standard General Construction and Steel Code of Practice. Okay, you have your for RCC. I think since you're in 7th sem, I think earlier before you had the IS code 456 2000 for your RCC, but for your steel, whenever you are dealing with steel structure or any specifications related to your steel, you have to consider this one, IS 800 2007. Okay, IS 800 2007 for your steel. Okay, so we were supposed to find out the partial safety factors, right? So we'll go to table 5. Table 5, number 30. We'll come to these things because we need all these things. So, uh, once we go on proceeding, we will have to go upon through the IS 800. Okay. IS specifications are there. The what are how much depth, how much size, how much is your length, all those things, safety factors, everything will be here. So you see here, this is table 5. Hmm? You can see here the table 5 here. Partial safety factors, all types of partial safety factors are mentioned to you here in your clause number 5.4 as per the clause number 5.4.1, the partial safety factor. So here you see the resistance governed by yielding is gamma MO. Gamma MO value is how much? 1.10. Resistance of member of buckling. These things you will need to know. So now for our welding purpose, the partial safety factor was how much? Gamma MW. This one. These are your gamma MW for welds. We are doing for welds now. So designing the weld portion. So gamma MW. Gamma MW is how much? If there are two more values regarding your this gamma MW, the partial safety factor for weld. So you have either shop fabrication or your field fabrication, right? So there are two different values, 1.25 and 1.50. Suppose you are designing the welding, you are designing this welding, you are designing this welding, gamma MW. So what will happen? You will have two choices of your values for gamma MW. That is, one is for soft fabrication and one is for your field fabrication. That means what? Suppose you are joining two metal parts. Okay, you are joining two metal parts with the help of welds, whether it be your fillet welds. I think I have talked with you about the different types of welds. Like one was your fillet weld, one was your this one slot wells, the other one was your groove wells. So depending upon not only depending but overall when you're using the partial safety factor gamma MW for the wells, what will happen? Suppose shop fabrication, no? You have to connect two metal plates or two members. Suppose two T members are there, two bars are there, big bars are there. You have to join that too. Suppose you have to join this and join this. Okay, you have to join these two. Now you are thinking that you will be joining them with the help of your fillet wells. So that means nothing but this one. When you are joining your fillet well, this is your you. It will be looking like this. From side view, if you see, this is your fillet will be looking like this. That means these two are connected. This is also longer from this side. From this side, this is this T is this upper portion is like this. It goes on increasing. Then this is also increasing like this. So you have to this T again this side. Okay, so to join these two you have to have you're joining with fillet weld. Okay, so now when you're joining these two, when you're joining this one top one and the bottom one, now it's becoming a T member. So when you're joining with the help of these two plates, with the help of this fillet weld, what is happening? You can take either the partial safety factor to be soft fabrication or field fabrication. Now when you take this, when you join these two plates on the on your fabrication side, that means on your shop or away from the site where suppose you have a construction site, You have a construction site here where the construction is going on. Okay, where the construction is going on. But when you take these, you have this construction. So when you have this, you will have what? Suppose this is your this thing. Okay, you will have your what? This is your member. Sorry, this is your field where the construction is going on. Now somewhere on the outer side, very far off place, you have prepared this. You have joined already these two in the shop. In the shop already you have joined, and you have in the shop you have joined, and then you have brought again these to the sides. Okay, this is a very big area. Okay, I'm just showing you as a small. Okay, I'm just showing you as a, now am I audible? Somebody said I'm not audible. Okay, to Achumi. Ma'am can't hear from me. Am I not audible? Hello? Okay, to now am I audible to you? Hello? Okay, to Achumi, am I audible? Let's do one sum today and then I'll leave. I'm having calls. Yes, ma'am, you're audible. Okay, okay. So now, see, suppose this is your shop, this particular place is shop of fabrication. Here all the metal parts are joined in this area. So your these two metal plates are joined here with the help of welding, and then it is brought to the construction site where your steel constructions are going on. This is a very large area. Suppose this one is very large area where construction, this is a spot, but on the that means here on the site itself your joining is not done. When your these two plates are joined and made here and then joined here only these two, so on the site itself for the construction of these, suppose one warehouse or a warehouse part, or maybe a small steel structure you are making here, steel bridge or something like that. So what will happen here, then on the site itself when you are fabricating, that means joining these two plates, you want to have this member and you are joining here these two plates on the site itself where your construction is taking place, you will be considering your this one, the field fabrication. That means on the field only your fabrication is done. But when this is not done, your fabrication is not done on the field but on the shop, then what will happen, you have your shop here where the fabrication is done and then it is brought on the field. That at that moment you are going to consider this partial safety factor, that is the partial safety factor for your shop fabrication. Okay, that means when you are designing, when you asked in your question to design, that means what you're going to do when you're designing, you'll do what you are going to uh, it is your choice, like whether you want to take shop fabrication or whether you want to take field fabrication. But suppose in your question it is mentioned like your fabrications or the weldings which are done, it is to be done on the site itself, so you have to take the partial safety factor from these column. That means 1.50 for the welding. And for bolts also, there are, when we will be designing bolts, you have to consider the same table number 5 for bolts, for rivets, for wells, the different types of partial safety factors, you can get the values from your table number 5. Then, so now once you know here, so that means basic step what we have done, throat thickness we are going to find out. We are going to find out the throat thickness first of all, 0.7s. Then the design shear stress, that means Fu by root 3 gamma mw. Gamma mw value you are going to get from IS code 800 2007 from table number 5, right? Then Fu you are going to get from the metal whichever is considered to you in your question or whichever you are considering in your design, right? Now comes your, after we have found or calculated the design stress, what we next step is what we will be designing the strength. That means the we'll find out, suppose you have joined two members, right? That two members where it is, okay, suppose these two members you have joined, we have to see that this joining, the joining of the weld by the with the help of weld which you have joined these two members, whether they are strong enough or not to carry any external load or not. Okay, so how you're going to check whether this connection which you have made, you have joined these two metal plates. Now these two metal plates, whether they are able to take these external load or not, how much strength is there? Like suppose you have to carry an external load of 50 kilonewton. So whether your weld is strong enough to carry this much load, 50 kilonewton load, that we have to check. So that we can check, that thing only we are checking now. Okay, we are designing. That means first is we'll, because since the strength depends upon the throat thickness, that means the shortest distance I told you. So first step is what you are going to find out the throat thickness, how much is the throat thickness with the help of the size of the weld. Then the design stress FWD is equal to Fu by root 3 gamma MW. Then we are going to find out the design strength, and design strength of the weld is how much? FWD PWD is equal to FWD, that is the design strength into, this is the design stress. So this into your length of your weld and the throat thickness. This is going to give you your design strength. So design strength of your fillet weld will be how much? This design stress into your, for how much length you are going, for how much length of the weld you are going to take. You are going to find out the design strength. So that is length L per meter length. Then the throat thickness. You have to multiply it with throat thickness. Okay, this got it, that how you can find out your how you can design your fillet wells. Now I said you that there are three types of wells. They are, your number one is your this one, fillet weld. Number two is your groove well, this one, and number three is your slot well. Okay, so fillet wells, you know now that isosceles, it looks like isosceles triangle. You have to find out the throat thickness first of all, 0.7 s. Then you have to find out the design stress Fu by root 3 gamma mw. Then you have to find out the design strength per meter length. That means FWD into length into the throat thickness. Okay, so in that way you can calculate your design strength of the fillet wells. Now coming to the groove weld, same, this is the basic that you have to know the throat thickness, design stress and design strength. In this way you can find out. Now what is your groove weld? Your groove weld is nothing but, suppose wherever you are joining these two metal plates like this, the this end portion of these fillet, sorry, the end portion of these plate and the end portion of these plate, you're taking these two and then you're joining these two. Okay, you're joining these two. So when you're joining edge to edge, that is nothing but your groove. That means any kind of groove you have, it can be U, it can be V groove, like here you see, it can be J groove. You're looking, this is this groove. Suppose your one metal plate is straight and one other metal plate is in this shape. That means there are different types of groove weld. Okay, depending, but mainly the groove weld means what? When you connect, with the help of weld, when you connect these two edge to edge plates or any kind of metal members from edge to edge, that is your groove. Okay, groove welding. That means you have this one, you see here, single bevel shape. When you fill up this with your this thing, the welding, it will be how it is looking like your a single bevel. Then you have, this is your square, right? This portion is your welding. Welding is done here, and these two straight metal plates are joined together. So this welding is looking like how the square. So square groove. Okay. Then you have this one, double bevel groove. This one was like this. Actually, this is like this. Okay. That means little bit circular kind. It's not a like I. This is like this. Like uh, like this. Okay. So when you have these portion twice like this and like this, that is nothing but your double bevel. This one was single bevel. So you have J groove, double J groove. This is your J kind of groove. Here you have two J's, from this side one J, and from this side one J. So when you see the pictures here, the diagrams are not properly done, but when you I'll give you an assignment also. Take the assignment like different types of groove well. What are the different types of groove well? Okay, let me write in the chat box. This is your assignment. Okay, assignment 1 is write the different types of groove wells. What are the different types of groove wells? Okay, so assignment number 1 is this. What are different types of groove wells? Show with diagram. I hope everybody has seen my chat box. This is your assignment number 1. What are the different types of groove wells? Show with diagram. You have to draw all the different types of diagram. Go through internet or go through book. Okay, and then you give the assignment. I think you from 28th you are going to be joining, right? Physical classes will be from 20. So when you come, today is 14, na? So when you come, you submit me these assignment. Assignment number 1 in your makes a small copy. There you write this assignment. Okay, each one of you make this assignment. Okay, so next, when you will have here also for single groove well, what you'll have the throat. How you can find out the strength of these groove wells? Same thing. Throat thickness you have to find out. Then you have to find out. Okay, one more thing. Throat thickness you will find out, but here in this case it is not a single. Sometimes it is a single. Sometimes it can be like this. Like this is like this. This is plate is like this. This plate is like this. So it is looking like V, right? So this is a single V groove well. But when your plate is like these, and like these, like these, like this, like this, like this. So it is double V groove, one top side, one bottom side. So this type of groove wells are there. So when you design, you know that you have to find out the throat thickness. So in your groove wells, what you're doing for single groove well, you will have what? The throat thickness of single groove V groove well is given by not only V, any type of single groove well is given by 5 by 8 into thickness of the thickness plate. Double groove well, thickness of the thinner plate. Okay, and slot well. I think when we do these problems on groove wells, we'll go on that. But since we'll start with the fillet wells, okay, so that you can understand properly. So when you are doing with the fillet wells, you know you how you have to design throat thickness 0.7 s FW, design stress FU by root 3 gamma MW, design strength, design stress into length into throat thickness. Now let us take a question. Okay, suppose now this is one question to you. That is what 80 mm into 8 mm plate is to be connected into 120 mm into 8 mm plate. So this is your 120 mm. This is your 8 mm. Okay, so 120 is the length. Okay, here now these two plates, sorry, this is your plate number 1, 80 mm. This one 80 mm into 8 mm. This is your 80. This is your 8. Okay, so 8 mm, 80 mm. Another plate is how much? 120 mm into 8 mm. And this is another plate. Okay, so these two are to be joined as a lap joint. It is mentioned to here in the lap joint. Okay, these two plates are to be lap joint. Lap joint means what? Overlapping each other. So this plate is at the top and this is at the bottom. These two have to be joined for some design purpose. Okay, so join to transmit a factored load. Now, what is the load that is to be carried? I told you just now, just a few minutes ago, I told you that why we find out the strength of these welds. Suppose you are connecting these two plates, why you need to find out or calculate the design strength, because to know like this is able to take this much load or not, because you have designed these, you have connected these two metal plates to join, you have designed these two plates so that it can carry a load of 125 kilonewton. So it is important for you to know, like when you join these two plates with the help of weld, whether that connection is strong enough or not to carry this much of load. Okay, 125 kilonewton of load. So here in the question, what is mentioned again? Providing 6 mm size of the weld. That means size of the weld means what? This one, size of the weld is given to you 6 mm. Now, when you know once your size of the weld, obviously you can find out your throat thickness. Throat thickness will be how much? 0.7 s. So, as you know, so that means your throat thickness is how much? 4.2 mm. Now, once we know this, we have to know what the design stress. This one. So design stress was how much? This one we have learned Fu by root 3 gamma mw. So Fu by root 3 gamma mw. Okay. Now I showed you this partial safety factor also. Fu is how much we have considered, considering Fe, the steel to be Fe410. Considering this, we are designing. Okay, since it is not mentioned here in your question, you assume yourself that the metal plates which we are using, and it is of Fe410. Now, when we consider Fe410, our Fu, the ultimate strength will be how much? Fe. So that means 410 root 3 into gamma mw. Now, gamma mw is what? Gamma mw in your table 5, this one I showed you gamma mw value. This one gamma m values you can find out. Gamma mw is here for welds. So how much you are going to take? Whether you are going to take it, see in your question, lab done to transfer a factor loader. It is not mentioned here that whether it is your field fabrication or your shop fabrication. So you have to consider. So you can write here one thing. You can write here that we let us assume the steel to be Fe410 grade, and your fabrication is done on the site. So that means when it is site fabrication or the field fabrication, you have your partial safety factor is how much? 1.50, this one. So 1.50 here. So now once you calculate these, you will get your design stress. Now once you get your design stress, you know the design strength is how much? Design strength is FWD, these into length into throat thickness. Now here in your question, the length of these weld, that means obviously these two are joined together. Now your weld length will be from here, welding is done here. Obviously here the welding has to be done. This one, this one, this one, this one. These entire portion has to be welded so that these joints together, these two plates join together like a like how you use the glue to join two parts. So in that same way, welding is used to join these two metal parts. So this is said to be your this one is said to be your length of the weld. Okay, but in your question it is not mentioned how much is the length of the weld, because if you move this plate little bit on the right hand side here, then obviously this is going to increase and this is going to increase, so your length will increase. And if you bring your to your left hand side here these plate, it is your welding is going length of the welding is going to decrease, so we don't know what is our length of the weld. It is not mentioned in our question also. So what we are going to do, we are going to take the find out the design strength per length for the per length key, because we don't know the entire length of the well. So to find out how much, this is our design. Okay, design means what, we will be finding this how much length of the weld is required so that your 125 kilonewton is resisted or can be taken by the member. Okay, so now when you have per length, you're taking the design strength per length, what will happen, L into throat thickness. L is 1 because we are taking per length, this one, per length. So FWD is this one, 157.81 Newton per mm square into 1 into throat thickness. Throat thickness was this one, 4.2 mm, this one, 4.2 mm. So what is our design strength now? Our design strength of the weld per length is how much? 662.802 Newton per mm. Right. Now, you know this thing, that is the design strength of the weld per length. So now for the entire length, we have to find out how much is your strength. So to find out these length, this is our design, that we have to find out the length of the weld. So effective length of the weld will be how much? This entire portion is your known as your effective length. Okay, so when you have effective length of the weld, how you are going to find out? The factored load into, okay, the factored load, meeting is going to end now. So, okay, so we have what? Hokato Achumi. Okay, if you are not able to hear, video will be simply uploaded also. You can just go and find out what was taught in the class. Okay, so see, factored load. Factored load is how much? This one already it is mentioned that it is factored load, factored force or factored load in the question. So factored load, if it is not mentioned, only the force is given, you know how much is the factored 1.5 into you have to do. So, but this is already factored. So this 125, this mentioned to you, and FWD is how much? This one, FWD is, yeah, sorry, this is this one, the design strength per length. Okay, so your effective length is found out how? This is PWD. Okay, so PWD is what? You have to find out, you have to do the factored load and you have to divide it with the factored load and the design strength. So once you do the design strength, you will get your effective length. So effective length is how much? 188.59. That means nothing but 189 you can consider. So that means we can consider our these lengths to be 189 mm. But how you will know? You know the total length, right? I think the class will end. So today we had two classes, first one and second one. This one was the second class. So I'll do one thing. I'll 5 minutes. I think now the meeting will end. So I'll share the link now with you all. Go and give the attendance. Next class I'll take in the second half. Okay. Second half I'll take the class. I'll, because I think you have project class, but you may not have started till now. So second half I'll share you the link. Join there. I'll share the link now. Wait. And the second class will continue. Okay. The second class will be in the second half. Let me share. Design of structure. Responses on now. Go to this link and then give your attendance. Giving your attendance. 52 responses. I hope you're getting the attendance link.
Ma'am, ma'am, hello, ma'am.
Response is not working now.
Yes, ma'am.
Okay, now you see. Now I think it is okay. You have third class. You have now. Ma'am is going to take the class. Do you know any idea? If she is not going to take, I can take the third class. Okay, just inform me if your class is not done. The third class, if your third class is blank, you inform me in the group.